right after lunch and butting up right against networking activities. So thank you for coming here. It'll be a fun few hours between after we get lunch to settle in and then get on to see the wonders that Austin has here. So this is session 3A. We'll be going over some of the NERC related standards activities from FERC Order 901, specifically milestone 3. Up here is a wonderful panel of the standard drafting team heads that are related to FERC Order 901, specifically on that milestone 3, as well as a not quite milestone 3, but very much related EMT modeling projects. So we'll be going over each of these, how NERC got to where there's a FERC order requiring specific standards enhancements. And I'll kick us off with just a brief overview of 901, how we got here, and then I'll turn it over to our standard drafting team leads. So NERC facilitates a standards development process that's governed by our rules of procedure and our standards process manual, which dictates specific development requirements. And it is an industry-led drafting team specifically drafted requirements for our standards. So NERC staff themselves, unless certain rules of procedures are enacted, typically will not develop a standard. And so these standards are designed to identify the responsible entities, the who's, the objectives those entities need to achieve, or the objectives that multiple entities needs to achieve, so the what's, and how often these performance-based targets would need to be, so the when's. So we'll be talking about who's, what's, and when's in this panel. But you may hear a little bit about the how's. The reliability standard text itself would not specify those hows. Within our standards development process, our facts and circumstances for each individual entity must be incorporated, and it's designed to have some flexibility in achieving the what's of the particular performance standard. And so all this is dictated in our standards process manual. Excuse me, still fighting some allergies from where I came from. And so I apologize for a little bit of the coughs every now and then. But related to 901 and the standards development process as to how we got here is the recent influx of newly registered entrants to the NERC process. So that previous standards development process is tried and true, typical utility practice. If you owned a generator 75 megawatts or greater, or some of the sizable synchronous units, you were part of the standards development process. Well, this new process has a bunch of new entrants. FERC, in releasing 901, saying we need to do performance requirement changes for registered, unregistered IBR, as well as IBR, DER, in the aggregate that materially impact the bulk power system. They also released an order to say we need to register more unregistered IBR. And so it would behoove me to say we're in phase 2 of that registration plan. The first phase was to identify the specific generator owner requirement changes for registering those unregistered sections of IBR. So our standard drafting teams will likely talk about the IBR related aspects that is applying to generator owners that include these new categories. So we had made a new category, category 2, generator owner and generator operator, and that is a facility anywhere between 20 MVA and up, connected to a 60 kV and above system. So we're in the middle of this. We've identified the category 2 GO and GOP revisions. Those have been approved, and we're beginning that sort of outreach for education through quarterly updates, webinars, workshops. If you've received a letter from our Senior Vice President, Howard Google, he's taking charge of trying to ensure the proper outreach to these entities get registered into the NERC registered body. And that's anticipated to complete within May 2025 to May 2026 timeline. And so we'll have more outreach, but at that point, we're expected to have the complete set of these new entrants. So while this is all happening, we need to have standard performance changes that apply to both the current set of registered entities, the oncoming set of registered entities that are now registered IBR, and then what remains. So IBR that's connected to the bulk power system, as well as this lump of IBR that's interconnected through our distribution systems that in the order is called IBR, DER, and we'll hear from our standard drafting teams that we simplified that term to just say distributed energy resources, to not be technology specific there. So 901 landed in October of 2023 alongside that registration order. It had 4 different milestones, 1 specific to NERC, and then 3 through the standards development process that would have ongoing November filings from 2024 into 2026, with the first milestone needed to be completed by January of 2024. All related to the IBR performance issues. NERC has released many major disturbances that effectively go like this. System disturbance occurs. Multiple generator owners of IBR assets or non-registered owners of IBR assets participate in this system disturbance. Our event analysis identifies a potential root cause and repeat. There hasn't really been much alterations, changes, model true-ups, what you name it. We've had some successes, but not a sweeping scale. And so FERC took notice of that, leveraged that previous practice, the previous major events. And if I could, and I apologize for FERC staffers in the room, I would summarize FERC 901 as we need to stop the tripping. And so a lot of the groundwork is related to our event analysis programs that I've identified, voltage dependent tripping or other non-performance to regular system disturbances that we expect on the bulk power system, and an inadequate performance of these specific categories. Hence why FERC Order 901 is specifically targeting inverter-based resources of the various categories I explained in the registration area. So where are we today? That January 2024, we filed our work plan, which said, here's how through the standard development process we are going to achieve FERC's work. That's a pretty much just a NERC only hurdle. And then where we bring industry along is, well, we need teams, standard drafting teams. They're built by industry representatives, headed by our fearless leaders to my right here. And we're here in milestone 3. That's due November 4th, 2025, and that'll be to develop specific modeling changes and improvements for all of those categories, including model validation and data sharing for all IBRs, including IBR DERs in the aggregate. Excuse me. Last milestone was related to performance-specific enhancements of BPS-connected IBR facilities related to ride-through and particular advancements there. That process took a significant amount of time, and for folks that were in our August ride-through conference, we greatly appreciate the input in order to make sure that those ride-through standards reached a consensus of where they did. We are then building up milestone 3 to use and leverage those existing standards, including milestone 2 standards, to identify a cohesive way of model development, data sharing, and practices, so that in the very end, we get planners and operators to study the potential bulk power system reliability issues and perform specific corrective actions, which will be finalized in milestone 4 in November of 2026. So quick summary of milestone 2. That was new PRC standards, PRC 28, 29, and 30. PRC 28 focused on the requirements of generator owners to install disturbance monitoring equipment and share that data upon request as a major summary. PRC 29 is a separate but equally valid concern that we had in our event analysis, that IBRs wouldn't ride through typical disturbances. Well, there's now additional voltage and frequency bands for IBRs, particularly to ride through grid disturbances for voltage and frequency. And it's a capability-based ride-through criteria. There is an exemption process, and that one, if I currently believe, is out for NOPR, specifically on certain requirement language in PRC 29. So that one is still an ongoing but filed standard for milestone 2. And PRC 30 is the requirements of a generator has identified a specific item in the plant, a response to disturbance, say a portion of their IBRs went offline. What are the requirements on the generator to identify a root cause, an analysis after a disturbance occurs? And then, okay, if this occurred in real time, we need to evaluate if it met specific ride-through criteria and performances. And so there's stipulations in there for PRC 30. Now we get into milestone 3, which builds on this work. And we've been through a year of talking through the specific performance requirements, and now we need to get these requirements in a model that's usable. So we'll have John Schmall from Project 2022-02 discuss this uniform model framework for IBR. In scope for that team is to establish the usage of accurate models for IBRs, as well as a framework to data share and model development. That focus will then be able to share those frameworks and the accurate models and leverage any sort of criteria, library, et cetera, on what makes an accurate model for IBRs. The standards there are both operational and planning. So that's our Mod 32, TOP3, and IRO 10 standards. In Project 2020-06, which we'll have David come up to present. It's focused on the verification of generation models and generation component models. It includes the definition of what makes a verified or model valid approach. So we'll have those terms of model verification and model validation, as well as the usage of performance-based data or stage testing in order to perform these activities. The related standards here are Mod 26, 27, and FAC 2. In milestone 3 as well is Project 2021-01, led by Harry. He'll provide how do these generation component models and all other models comprise this interconnected system of models that either an operator or planner could use. It'll align that verification and validation against actual system operation and develop specific criteria and process to communicate any sort of deficiencies in the system model. Of concern primarily is Mod 33, where PCs are able to perform this, and we'll hear more from Harry on that specific project. In not the milestone 3, but kind of part of milestone 3 and closely following, we'll have Dan Kell, who leads Project 2022-04 to establish, or that's tasked to establish EMT studies for IBRs during interconnection and align with those other milestone 3 projects for the model development, as EMT models have been known in the industry to closely follow on interconnection and need to be aligned here. And so you'll see similar standards. This team is planning to revise Mod 32, FAC 1, and FAC 2 to help with model procurement and model development. And so this is all to key us up to use proper models for operation studies and planning studies. We might have a little bit of an overlap in some of these terms. I know that certain areas have an operational case that's less than 1 year, but many operators won't use the less than 1 year case. They might do a seasonal type of studies. And so we have a little bit of scoping to figure out exactly how does this relate to our NERC expectations for both planners and operators to use these new standards and revised standards to accurately model and validate IBRs. Both of those SARs are in development, and in Q1 of 2026, we'll start seeing development here. So I just wanted to give a brief overview of where we came from, where we've progressed in sort of FERC 901. And I'll be turning it on over to our fearless leader, John Schmall from Project 2022-02 to kind of walk through the uniform framework for IBR.
So good afternoon. Thank you. I just want to make sure you're still alive out there. Yeah, so as JP mentioned, I'm the chair for the Project 2022-02, the Uniform Modeling Framework. Really where we're at, we probably have drafted all the initial draft of what we think addresses the FERC 901 SAR. I think aligned with that is really our project existed before FERC 901. We always had like a DER line item in Mod 32 was kind of within our original scope. Obviously, FERC 901 talks a lot about IBR, DER, and and it kind of wraps them all together. I think so. My slides today are really going to jump right into, not really get into a lot of the administrative stuff, but really get right into the nuts and bolts and some of the technical challenges and some of the feedback we've received and perhaps some of the pain points on where we're going with this. So one of our first tasks, and again, this goes back even before FERC 901, was to try to develop a DER definition. And I think the challenge with that obviously being, if we're going to start saying, well, you need to collect DER data and model DER, I think it would make sense that we actually define what those resources are. And I think the unique thing about DER in particular is it's not a specific technology, but what really makes DER is where it's connected on the system. So our draft definition right now is generators, energy storage technologies connected to a distribution system that are capable of providing real power and non-isolated parallel operation of the bulk power system, including those connected behind the meter of an end use customer that is supplied from a distribution system. So, I think, and this is kind of modified a bit. We've put out some earlier drafts before FERC 901, tried to leverage some of the NERC definitions. At one time, we'd kind of considered, whether we should try to use distribution provider, which is a NERC defined term. I think we've received some feedback on that. Looking at really a lot of different industry definitions that are out there for DER. And I think the point being, for our purposes on DER definition for a NERC glossary, it's really to be applied in the NERC standards. So we're really trying to focus on that reliability concept in defining these types of resources. So, and that's where we kind of ended up with using distribution system. It's not a defined term, but I think it's kind of well understood, particularly in those local regions where it's applied. And I think it's really at this point probably the best that we're going to come up with. I think in terms of some of the feedback we've received, I think in the past, I think we've had some concerns that, we have this statement around included behind the meter of a customer. And I think from a practical standpoint and what we want to include and what we want to make sure that we collect data on and represent in our transmission models is really includes that as a specific line item, because it's not just generators that are connected to the distribution system, but I think one of the biggest components of it is probably the most prolific and growing is probably the typical residential rooftop solar, and understanding that impact in aggregate as it rolls up to distribution stations, transmission level stations, and understanding how to account for that, I think is probably very significant in applying a reliability study analysis. I think one of the other concepts that we've received in terms of feedback so far from industry is also this concept of around the definition does not really include a threshold, to say, well, I should only need to consider DER if it's above a certain threshold. And I know the team has had a lot of discussions on that. I think some of the challenge being, from a very basic level, I mean, a DER is a DER. It doesn't matter if it's a small or large. I think the other concept being is it's very challenging to apply a threshold in a definition. I mean, is it based on an individual basis? Is it based on aggregate? Is it based on something else? So I think the drafting team conclusion was really basically that, DER should be DER, and it shouldn't necessarily rely on that kind of a threshold. I think the other complication with a threshold, obviously, being if you've established a threshold, I think that actually puts a more challenging compliance burden on the entity that needs to collect DER data, and now they have to say, well, I'm below the threshold. Now they actually need to provide evidence that they're actually below the threshold. And what does that mean? Well, essentially that means they need to collect all the data anyways. So I think that is kind of where we're at on the DER definition. Going through, just kind of going through some of the red lines that we're proposing, and just first going through with mod 32. This is really on the applicability. I think nothing here too controversial. Load serving entity has been delisted from the NERC registry for a number of years, so it's well overdue to be replaced by distribution provider and the applicability. The rest of the deletions is really around this concept of the FERC or the NERC functional model, which is really just a historical artifact, never was really officially approved. So basically just kind of deleting that kind of text in the applicability. I think one of the key points, and this is in the requirement R1, really around the planning coordinator and transmission planner model data requirements and reporting procedures. We basically added a line item that needs to basically include requirements for model submissions in accordance with the criteria of acceptable models, which are maintained by the ERO, the Electric Reliability Organization, or in other words, NERC. I think this is really the heart of what provides that modeling framework. And I know in the FERC 901 orders, there's a lot of, probably several references to what they would call industry approved models or a model library, generic models. There's several references within that. And I think obviously what we learned in, there was a workshop in Phoenix in January, a lot of discussion with industry around some of the pitfalls of defining a specific model library, and at the end of the day, the objectives of the FERC order are not just to have a model, a kind of a uniform framework or a structure or model library, but also have accurate models. And I think the conundrum there is, if I define, well, here's my set of models, and you can only use these models, particularly as technology rapidly evolves, you get to a point where, well, the models of the data set that you picked aren't reflecting my facility. So as an alternative, basically the drafting team has been working with NERC staff and developing this basically criteria for acceptable models. And it's essentially provides a framework that allows for, and really defines what makes a model acceptable, what makes it usable. I think some of our feedback in particular on this one from industry has been around basically referencing a document that is not part of the standard. And I think one of the challenges that we've encountered obviously is this document, as JP had mentioned, FERC 901 is applicable not only in the planning realm, but also in the operations realm. So this is a document, and it's not really, it's still maintained by NERC, and we'll get into a little more details of that. But I think as a practical matter, the drafting team felt it would make more sense to have a single document that could be referred by multiple standards rather than trying to put that information into multiple standards directly. Talking a little bit about this criteria document, and it's been out in draft. I don't know if you've been part of the drafting team, or I think an observer on the drafting team, I think it's definitely been out there for your review. But if you haven't been on that and are interested, please, I would say look up on the website for the project page and try to sign up as an observer. But essentially, there's probably nothing too onerous on this document. I mean, essentially, it's a criteria for acceptable models, defining usability requirements. What does that mean? Well, basically, if I have a model that doesn't initialize, I've got a model that, requires a lot of, very complex folder structures in order to use, and it's not really compatible with building interconnection-like cases. Those are things that aren't acceptable. From a other perspective, there are some nuances between using a model in a planning case versus an application and operations. Those are kind of addressed in this model. And then probably importantly, there is a process, if there's a need to change the criteria, there's a process for doing that, and it's an open stakeholder process. The other component of this document is also basically identifying unacceptable models list. And this is should be very familiar, as I think NERC has already published essentially this list previously. And I think the list that's in the document is essentially aligned with that. And I think the other component of this document is alongside the unacceptable models list, if you happen to have something on the unacceptable models list that happens to be the best model and a reasonable model for your facility, there actually is a process within the document that you could potentially use that or have something taken off that unacceptable models list. So this is just kind of a high level process for how you revise the document. I mean, there would be a submission request, there would be a review by ERO, a 45-day industry comment period. Essentially, the NERC RSTC was probably identified as an appropriate body to review that determination. Ultimately, would go to the NERC board and basically a public notice of implementation of any changes. I think in a similar but slightly different process for changes to the acceptable models list. So if something needs to go on it or off of it, kind of a similar process, but submit a request, go through some ERO staff review. And they could also work with, subgroups, working groups of the NERC RSTC, but ultimately would go to that RSTC review and recommendation, come back to a NERC officer, public notice, and then again, understanding what was the technical rationale for putting something on that list would definitely be defined. I think ultimately the unacceptable models list is really, things that are models that have fundamental flaws in how they represent things is really the intent of that list. So going on to R2, this was something that came directly out of the FERC orders really around estimated data. And ultimately, particularly when the FERC order essentially required, unregistered IBRs and DER data to be provided by some entity, a NERC registered entity needs to have that obligation. The idea being, well, there are times when that data is unable to be gathered, sketchy, so forth and so on. And within that FERC order, they actually allowed for this provision of estimated data. So you can provide an estimate of that data and parameters, an explanation of the limitations of that data, and then basically a method that was used for that estimation. So that's basically rolled into R2, where essentially the functional entities are providing data associated with according to the PC and TP data procedures and requirements. Going down to the attachment 1 in mod 32, and attachment 1 was it's really a subset of the requirements on the planning coordinator and transmission planner, with the idea being their data recording procedures and requirements need to cover all the items in attachment 1. I think one of the clarifications we ultimately made in attachment 1 was really to make that very clear. Attachment 1 does not assign a obligation to a specific functional entity. And I think this is aligned with what's in R2. If you looked in requirement R2, the functional entity's obligation is to provide data in accordance with the planning coordinator procedures and requirements. So we tried to make that very clear in the heading. Getting into some of the detailed line items in the attachment 1, basically adding the existing side on the steady state already had generating units. We just kind of made some clarifications that explicitly included storage units. There are some footnotes talk about a little later. And then on the dynamic side, where they used to have very generic statements about wind plants, photovoltaic, we basically modified that to identify wind plants that are really associated with with type 1 and type 2 wind turbines that are not considered IBRs, and then have a specific line item for inverter-based resources, really trying to be directly responsive to what's in the FERC order about IBRs. I think the sub-bullet on the IBRs is really associated with, what are the capabilities related to momentary cessation, related to tripping and ride through, which were specifically identified in the FERC order. I think going down on the next items that are really added in the attachment 1 is really collecting data and making sure those procedures are associated with acceptable or aggregate DER data for both steady state and dynamics. Again, identifying some basic information, probably a minimal amount of information that is necessary, in terms of location. Well, what's my real power capability? What's my DER type? Am I a battery? Am I rooftop solar? Am I something else? That needs to be identified. And then kind of on the dynamics side, again, DER data, understanding what those capabilities are with respect to momentary cessation, tripping, ride through, et cetera. I think one very key point, probably a difference between the transmission connected IBR and the DER that is noted in the standard is there's information that can be used to infer what those capabilities are. I know Spider Working Group has had several reliability guidelines around parameterization, data collection, with the idea being, I don't necessarily need to know the exact model for every rooftop solar, but I can have a very good idea of what their capabilities are based on, what was their installation date, knowing the local regulations. Are they requiring, 1547, 2003? Are they requiring 1547, 2018, so forth and so on. So just wanted to highlight that that concept is in there. Going through some of the footnotes. So I think there's a couple of places in attachment 1 where the footnotes are basically duplicated. So we kind of restructured the table a bit. One table of footnotes that can be used. I think one of the key points probably in footnote 5 and 6 are really kind of talking around this obligation around unregistered IBRs in footnote 5. And this was really something that came out of the FERC order. They pretty much identified that, a transmission order should be responsible entity for providing providing data for unregistered IBRs that, I think we included that are not DERs. So something that's basically connected on the transmission system that might not meet the NERC registration criteria, but would still be potentially impactful in terms of reliability impacts. And then I think from the footnote 6 is really kind of around this DER data that may or may not be connected to a registered distribution provider, and really trying to provide out some guidance on who the registered entity that should be basically responsible for providing that data. Typically, it would be a distribution provider for data that's connected to their distribution system. If it's an unregistered distribution system, it's basically that next registered entity up. If there's no registered entity between that DER connection point, who's the next registered entity up that's connected? So if it's an unregistered DP that's connected directly to a TO, it would be that TO's responsibility. If it's an unregistered DP that's connected to perhaps another registered DP, then it would be that registered DP's kind of responsibility to have that data. And again, with the concept being, if they are unable to gather data, they can also have that option to use estimated methods. And then just wrapping up very quickly, I think these are the TOP3 and IRO 10 edits are actually very minor in a sense. I think we just wanted to be responsive to the FERC order. And basically, there's a list of data items that, transmission operators could potentially need in their operation planning analysis and real-time assessments. We just kind of added IBR specific data and parameters, and we think that is essentially what the FERC order was directing, and making sure that operational or operation studies reflect that kind of information. And again, within the provisions of providing data, again, a reference to that criteria for acceptable models that is maintained by the ERO. So again, I think in TOP3, the first requirement R1 is really around the transmission operator. R2 is really around the balancing authority. And then in IRO 10, very similar concept, basically on the reliability coordinator studies. And I think all of those edits are very, very similar and pretty much self-explanatory, I think. So with that, I think that's my final slide.
Thank you so much, John. Up next, we'll have David Marshall, who is in charge of the validation of all these generation components. Up to you, David.
Thanks, JP. Good afternoon, everybody. I'm David Marshall. I work for Southern Power Company. We're a wholesale energy provider with over 13 gigawatts of generation all across the U.S. It consists of gas, wind, and solar plants. I'm here to talk to you about verification of models and data for generators. And as you can tell from the project number, 2020-06 has been around for a while. I'm actually not the lead. Brad Marzalowski is with the ISO New England. I'm actually one of the new members. And as a part of our group's initiation for new members, they asked me, they kind of told me to come up here and present this material to you. So hopefully I'll get our point across, but please ask questions as you need to. Okay, just a brief outline of what we're going to cover today is just to provide you a history of 2020-06, some highlights of our current standard 2026-2. It includes, I think JP kind of hinted at this, the model verification, validation definitions, how we're handling IBRs, whether they be registered or unregistered, our approaches to EMT that's included in the standard, system events and how that kind of plays into the validation piece, and then a tentative timeline. Okay, so jumping into the history of 2020-06, as you can tell, it's been around since 2020, and so there's been a lot of activity that's occurred. Pre-FERC Order 901 as a sort of a fallout from the NERC disturbance report, starting with the Blue Cut fire. Our IRPTF reviewed all the standards. When they reviewed Mod 2627, that's how our project got started, was trying to close the gaps where IBRs were not included in those standards. So including those in the standards, or not really addressed in the standards, and then also requiring GOs to verify their dynamic models, because there have been issues with the models not really reflecting actual performance. That group went through several drafts, went through 3 drafts, and all those went out to ballot, but then they had to call an audible because the milestone 3 standards needed a definition for IBRs. And so they tackled that issue. And by the time they pivoted it back to the standard, FERC issued order 901. So then 2020-06 project was then SAR was modified to include, some of those things that were out of that. Main things that were added were, and we'll cover these a little later, verification process, addressing, the registered and non-registered IBRs, and then validation with actual system data. Okay, so just covering a little bit of the highlights here, and really Mod 26 is combining the current Mod 26 and Mod 27. Mod 26 covers volt var control and validating, basically ensuring model performance there. And then Mod 27 is tackled the active power frequency control. And so what our standard is doing is merging those two together. We're defining, and so these next several bullets here, I'll have further slides on that, but we'll just go through them real quick. It's going to include defined terms for model verification, model validation, addressing modeling for registered IBRs, as well as synchronous generators, adding EMT models for the requirements, and then providing a process to improve the fidelity of the model itself, which includes the verification process, but then also a validation process. Okay, so first we'll tackle the definitions of model verification. So the definition that the team came up with was a process for confirming that the model structure and parameter values represent the equipment or facility design and setting by reviewing equipment or facility design and setting documentations. So essentially what we want for verification is making sure that your model, the components match the equipment that you have, but also the parameters that are set in the field. Do they match the settings that are actually in the model, or the parameters that's in the model? So just verify that right structure, right setting that's in the model. So model validation, the definition there that was developed was the process of comparing measurements with simulated results to assess how closely a model's behavior matches the measured behavior. So essentially what we did was this validation process is now taking actual system data and comparing that to how the model predicted it and looking at that mismatch. All right, just to kind of provide more of a conceptual view of what we include in the standard, here's the model verification process. So this is checking structure, making sure parameters match. If you're a new generator that's being commissioned, we also have TOs in here because fax devices and HVDC are also included. So if you're recently commissioning a facility, or making changes to an existing facility that affect the dynamic response. The GO or TO is supposed to provide that updated model to the transmission planner. And the transmission planner is going to review that model, and does it meet an acceptability criteria. And that acceptability criteria is something that's required that the transmission planner establishes up front, makes it visible so that GOs know what those requirements are. So as they review that acceptability criteria, really the process is the model accepted? Does it meet those acceptability criteria, or is it denied and it goes back to the GO to refine? Okay. So next is the model validation process. And here again, a conceptual way that it's being handled in the standard. So in this case, so the TP and the TOP really have to work out how is the transmission planner going to know that an event occurred, so that then they know to go get the data from the generator. And so what we've established in the standard is that they work out that process ahead of time, so that whenever, as the TOP is monitoring system events, whenever an event meets a certain threshold, they have a process in place where the TOP would notify the TP, and that the TP then would be able to request the data from the generator owner, so that he has that data to compare to the model. Right. So moving on to the next highlight topic that we talked about was registered, unregistered, and DERs for IBRs. And so essentially mod 26-2 is really going to tackle the registered IBR on this list. There's currently going to be a new standard being developed, still within the milestone 3 timelines. And that standard is going to tackle the unregistered IBRs and the DERs. Okay, next highlighted topic is our approach to EMT models. And so really, a lot of the transmission planners on our team really was emphatic about including EMT models in this standard. And one of the reasons is because they're saying that you can't accurately determine ride-through performance of an IBR without having the EMT model. So the way the standard is trying to address that is any facility that's commissioned after the effective date of the standard, they would need to provide an EMT model. There is accommodations for in the process, though, if transmission planner needs EMT models for facilities that are legacy. The transmission planner has the ability to go and say, hey, I need these, in these areas, I need EMT models for that. But also the standard acknowledges that if, say, for instance, a GO, some of the challenge that GOs have is that they're solely reliant upon the OEMs to provide this information. So if the OEM is no longer in business, or if the OEM no longer supports that product, that's going to be difficult to do. So we try to split the balance of getting the TP what they need from legacy facilities, but also from providing a way for GOs to meet that requirement if they not getting the support that they need from the OEM. Okay, and then the final topic here is system events for model validation. And really, I talked to you a little bit about that earlier with the conceptual view, but this is really trying to say, the transmission planner working with the TOP, develop that process. What's it look like? What events am I looking for? How am I supposed to communicate, and how quickly do I communicate to the TP? Also, you got to account for the time that the GO still has that data according to PRC 28. So the TP will request this disturbance data from the GO or TO to perform that model validation. And really, the TP, once they receive that data, they're going to use something like a playback method to compare that model output to the disturbance data for that validation piece. Okay, so we're wrapping up here. This is our expected timeline. We're expecting to Right now, we're reviewing the standard as it is, going through some quality checks and things like that. We're estimating that initial ballot posting is going to be April 17th. And what we're hearing is that we'll be able to have up to a 29-day comment period. I think 29 is kind of what's being settled on, as I understand it. But so that'll provide ample opportunity for people. Here's my plea from our team is if you're involved in the NERC balloting and commenting process, I ask, get involved, and to the extent that you see things that don't work, rather than say no, just say this is what would work. So, our plea from our team is provide solutions to how we tackle this as an industry. And here's a list of the team members. To the extent that you can't figure out how to write it down, one of these people, reach out to them and let them know what you think. And that's it.
Great. Thank you, David. Up next, we'll deal with these funny system component models, and I'll have Harry Singh take it away. He's our lead from Project 2021-01, and this will be covering Mod 33.
So, well, a big Texan howdy to everyone. Howdy. Well, so it probably is not evident by looking at me that if I claim to be a Texan by origin, I don't have the right accent. I'm not wearing the right hat, but hey, that's my claim to fame. My name is Harry Singh. I am honored to be the chair of the standard drafting team for this system model validation with IBR standard. Well, you've heard by now that from John how we're all going to use some acceptable models, all from the acceptable list of models that has been vetted and verified by the highest levels at NERC, standing committees and so on. And then for the Mod 26 standard, it's going to be all verified and validated models. So I guess the question is then, why do we need another level of model validation? Why do we even need system model validation? It seems like we are doing a lot of good due diligence with all the component models with those two standards. Well, this applicable standard for system model validation is a currently effective standard, Mod 33. It's been in existence for probably 7 to 8 years. And so I kind of think of it as almost the last line of defense to try to identify any erroneous misbehaving model that might have crept through the process. It's the last quality check or quality review, quality control, if you may. So that to me is the objective of system model validation. And well, the FERC order, of course, still emphasize that even though one wants a component model verification validation, then a plant level verification and validation, but you also want to have system model validation. But the question is, what is a system model? Well, if I'm representing the city of Austin Muni, well, my system is my system model. Maybe if I'm, representing maybe a utility up in the Houston area or the Dallas area, well, my footprint becomes a larger footprint. That becomes the system model. And if we talk to our friends from ERCOT, well, it's the entire ERCOT system, which is the system model. So the issue is, well, really, since all this work is being done to address what is being said in the FERC Order 901, so the first order of business for the drafting team here was, well, what exactly is the system model per the Order 901? What, in their mind, what are they referring to when they talked about system model? It turns out that if one looks at the order and you have some relevant paragraphs and quotes here, but what you see in the bottom, that footnote 92, that describes the meaning of system models in the context of the FERC order. And it says it's collectively referring to planning and operations transmission area models and interconnection-wide models. So it's kind of casting a very wide net. It has everything. And so the question really then, I think, became for the drafting team, we have to address the Order 901. The existing standard, which is the MOD 33, really applies to what we may consider a subset of this term as defined in the order, which is the planning transmission area model. So how do we really, in a way, reconcile what we have with what's in the order? Can we even reconcile it? Because we would have to explain it. Then there is a paragraph there that also talks about model validation. You saw from David that there are some defined terms developed now or proposed for model verification and model validation. Well, whether one is doing a component level, plant level, or system level, the model validation definition that applies should be the same. So I think the definition that the drafting team has come up with is, if you look at the last sentence over here in this paragraph, it pretty much follows what is being said there, that you're going to compare the result of system model simulation against actual system operational behavior, which actual system operational behavior typically comes from recorded data. One, as I said, when one has to update any standard, one is trying to determine what are the applicable directives from the order and trying to see if what needs to be done either to an existing standard to revise, modify it, update it to meet those directives, and or if a new standard is needed, because the existing standard doesn't lend itself very well to meeting these directives. These are all, given that all the directives are to address the any special needs for IBR models and the validation. We have it here, but I think what you want us to focus on is that really the three words that get used very much in the order are coordinate, validate, and update the models. So there has to be coordination needed, which you heard earlier from John, the uniform framework, the validation that needs to occur at every level, and then you update the models based on what your validation finds or your verification finds. These are so in a way, compared to maybe some other standards, the MOD 32 and the MOD 26, there are fewer directives that are applicable to the system model validation. But that's really because, as we talked about earlier, by system model, we are just bringing together a lot of things that have maybe the activities of validation have already occurred at the component level. So given with this background, well, what was our approach? And really the approach is, I guess the old golden rule: don't break something or don't fix something if it's not broken. So is there something broken in the existing MOD 33 that really makes that standard inadequate for high penetration of IBRs? Yeah, the standard was written for a realm when, we had very few IBRs or no IBRs. So, but is there anything fundamentally in there that will not work when you have high penetration of IBRs? Well, the first thing is, as we talked about earlier, this aspect of what's a system model or a scope of system model. So the existing mod 33 talks about system model validation of what footprint? It's the planning coordinator's footprint, not the interconnection-wide footprint, just the planning coordinator's footprint. Can this be squared with the scope of system model in the order? Well, that was one issue that the drafting team tried to resolve. Does the applicability of the standard, does it need to be augmented to now apply to some operations entities also, like a transmission operator or reliability coordinator? And that's because, if you recall, that footnote 92 in the order talks about both planning and operations transmission area models. So does it really need to, this need to happen? And then finally, how do we address the interconnection-wide model validation? Because that too is part of the system model definition as per the order. Now, given if we can do all this, if we can resolve and reconcile all the, what is truly a system model, what falls within the scope, then do the existing requirements of the mod 33 standard, are they adequate? Will they be adequate for some higher penetration of IBRs? Well, what about the final bookend? If you have a system with 100% IBR penetration, would they be adequate? But remember, if we modify requirements to address a 100% IBR penetration, then it still has to work for 0% IBR, because there could be some parts of the system that don't have that much of IBR penetration. So can one even have a one-size-fits-all type of mod 33 standard, regardless of the penetration level of IBRs? So those were the questions that kind of we grapple with. And I think finally we said, well, can we make any modifications? This will be the holy grail. If we can make the modifications that are penetration level agnostic, boy, you have just this one standard that covers everything. So that was really the 4 or 5 questions that the team tackled in order to determine the path forward. Just going to take a moment to put this all in perspective, that what you see on the left-hand side is the mod 32 attachment 1, which is the standard that John talked about, which has all the component model data. We have all these various component models. What is getting added really compared to the existing mod 32 is having some 3 different new types of IBRs, registered, unregistered, and aggregate IBR DERs. Well, that's what is driving all this. But ultimately, at the end of mod 32, one gets a interconnection-wide model. We refer to it typically as a base case, a Eastern interconnection base case, Western interconnection base case, or the Texas interconnection base case, so on. But it's an interconnection-wide case that results. Now, the mod 33 standard, it says, talks about system model validation, but it, as we mentioned earlier, it is applicable to the planning coordinator in the existing standard. But by having it applicable to the planning coordinator, are we effectively, at the end of the day, are we effectively able to validate the interconnection-wide model? And I would say the answer is yes, because if you have whatever n number of PCs in an interconnection, and if each of them is validating their own footprint and whatever is at the seams of the footprint, then at the end of the day, if all n planning coordinators have done their system model validation per mod 33, you effectively have landed at an interconnection-wide system model validation. So I would welcome any comments you have later on this, I would say, hypothesis, but that's where the drafting team is. And given that, what are the the questions that we asked ourselves, what are the answers we came up with? So as I said, we were really trying to, the overarching question was, is the existing mod 33 inadequate for system model validation with the high penetration of IBRs? And first question, can the scope of system model be squared with order 901? And the answer is yes. Well, why? Because even though the order 901 throws in an operations model into the mix of system models, but we are still talking about offline operations models, not the real-time operations model like an EMS model. Because if it's a real-time EMS model, well, that's the actual system behavior that you're comparing this to have model validations. So you're not going to compare the same thing with itself for validation purpose. So the intent there is offline system models, but it's like a base case. You can have a 5-year out base case, which is a planning case. You can have a as-built system base case, which is the operations base case. So you're still talking about offline models. So that part gets addressed. Interconnection-wide model validation, that is explained by the previous slide that we had, that if each PC does what they're required to do per mod 33, then effectively you have validated the interconnection-wide model. So given these, rationale that the drafting team came up with, we then said the next question, well, is there anything broken with the existing mod 33? Or does anything need to change over there to address the higher penetration of IBRs? And the answer we came up with is, no, it's adequate. And it's adequate, why? Because remember, as JP mentioned in the introduction, the NERC standards are all about the what. They don't tell you how to do something. Now, when it comes to system model validation, well, you have to do the validation. You have to have certain characteristics of how you do the validation. But how exactly you do it, well, that cannot be covered within the standard. That has to be in the associated technical guidelines, technical rationale. So what we have done is we have tried to not touch the requirements, which are the what of what needs to happen, but we have fortified the technical rationale and the guidelines associated with the standard to explain how the system model validation can be done, whether you have very low level of IBR penetration or a high level all the way to 100%. Because it's like we probably have heard, from maybe our college days that everything is a science and an art. Well, a lot of the art part of it cannot be put into a standard, but it can be put into technical guidelines. So we have drawn upon maybe some industry documents on system model validation and included the relevant portion in the technical guidelines supplementing the standard. But effectively, the standard is not much changed on account of this, Order 901. Let's see. So what is the final work products? We just made some editorial modifications to mod 33 requirements and measures. And the whole focus was to improve the clarity and consistency of those requirements. No substantive changes. Again, emphasize, no substantive changes. It's just improving the verbiage so that some of the confusion goes away. I also already mentioned about we develop or enhance the guidance on the how part to support the what part. And that guidance talks about each part of the standard. So there is guidance on steady state system model validation to support the corresponding requirement. Similarly for dynamic system model validation. And then what is the mismatch criteria recommended how the model can be then improved or updated once you do find some problems. That's addressing the FERC order of having updated models or making the models up to date based on the validation process. And then finally, you can do all this validation only if you do have access to that real-time operational data. So, so far, some of you may be familiar with the standard PRC2. That's all about disturbance monitoring equipment from where one gets a lot of the recorded data. That has been supplemented, as JP talked about, in the milestone 2 by the PRC 28 standard, which for IBR plants. And that's so between those two standards, one should have enough of the real-time data sources. And then finally, we hopefully have been able to demonstrate that all the applicable Order 901 directives are met with this approach. So that's where we stand today. As maybe others talked about, the standards will be posted for comment, and we'll be looking at the industry feedback. Thank you.
Thank you, Harry. Now we've heard a lot about the milestone 3, and I said that there's a project that's not quite milestone 3, but really related. So we have Dan Kell here, who's leading up project 2022-04 related to EMT modeling. And this would follow on the requirements that we explained here. So take it away, Dan.
Thank you. My name is Dan Kell. I'm the Global Director at Hatch. I'm responsible for our Renewable Transmission Distribution Group. And before I came up, I was just reminded how long I've been doing this. I put myself through university as a janitor at a steel mill. The original large load required very on-demand power quality issues. Anyways, a few years later, fast forward, I'm doing my graduate research. I'm creating EMT models of this furnace to do flicker mitigation on it. I'm back at this rolling mill, hooking up this metering. A guy looks at me like, "What are you doing?" I start explaining it to him, and he says, "Aren't you the janitor?" So I was like, anyways, I was pretty happy to hear when Sergey said that my thesis from 2005 is being used for large loads and looking at flicker and everything. I even sent a text to my kids saying, "Look, at my research is still being used." And they said, "Where are my gym shoes?" I got an answer, so I guess I'm all right there. So again, the project that we're looking at now is around EMT modeling. And I'm going to go on a couple tangents here as I'm discussing it, because this is extremely important to the industry right now. Again, I also want to leave everyone with the mindset that this is not something new to the industry. This is something that we have been doing for a long time. As we all know, the bulk power system in North America is going through a rapid transformation. You know, it's analogous to like we're trying to rebuild a car while it's running, while keeping the engine going, putting a new engine in and see what we can do. And this is all due to this high penetration inverter-based resources. And of course, the transmission planners and planning coordinators are very concerned about the lack of the accurate information and models needed to provide these EMT type studies during the interconnection process and planning horizon. Now, the growth of the inverter technology has pushed conventional planning tools to their limits in many ways. And again, on a side of a tangent, again, coming from in the HVDC industry, the original IBR, this has always been the case for us. So again, this is not something that we're introducing new that we'll talk about a little bit later. But now the TPs and PCs are being faced with the need to conduct much more detailed studies using EMT models for the issues related to this resource integration. Now, again, as the scope of this project relates to the Milestone 3 standard development, as was mentioned, we're not actually a Milestone 3 project yet, even though we may be later on. It's sort of up in the air right now. So we have no assigned FERC directors from the FERC Order 901. And again, this project is going to be developed in tandem with the Milestone 3 projects. But again, we're not right now considered a Milestone 3 project. And again, as I mentioned earlier, it's to address the reliability risk presented to the bulk power system due to the observed systemic differences in IBR performance and modeling. And again, that's one word I don't like in this description is like, it's not systematic. It's there's a few bad models that are really ruining it. There's some really good models out there. So I think we have to just sort of like, as we get through it, understand that it's the process of where we're going to get to that's going to be very important. You know, and again, so we're looking at creating opportunities to enhance the generator interconnection requirements and study processes through the enhancements to the FAC 001 and 002. Again, this project is going to continue to address the reliability related needs and benefits by ensuring the TPs and PCs have the models and tools necessary to adequately do these reliability assessments under increasing levels of, again, the IBRs. Again, I think we all recognize that this is going to require a good collection of EMT models by all applicable entities and TPs and PCs to conduct the studies where needed. And I want everyone to look at that sentence, EMT studies where needed. Okay, we're not looking to say everywhere. It's very, very applied to where it's required. Again, the SAR has been around for a while. It was accepted on July 19th, 2023, and you know, great team from all sectors. And again, I just want to point out there's 5 Canadians, 5 Americans, 1 Australian. I won't get political, but you know, we're working together, and I want to continue with the North American Reliability Council to continue working together, regardless of what anybody says. You know, I'm not quite ready to be the 51st state. So we have had a little bit of a slow process on it, and that's mostly due to the fact that I think we're not a milestone 3 project. There's a lot of other projects that are coming, and we're working with our counterparts in these groups. But the one that we have had is that we have submitted the FAC 002 for industry feedback back in earlier Q3, Q4 2024, and we've got the feedback. And we recently just assigned a smaller task force within our group to look at the questions that came back. We also made the decision to start going ahead to make revisions on Mod 32, which, as you heard, is also being worked on by somebody else, but we're sort of working in parallel to make sure that we're aligned on some of the changes that we see we may need that would come out of it. Some of the other items that came up during the drafting team issues, and this is kind of interesting, and sorry for the acronym heavy standard here, but the IRPS submitted the RSTC ASAR for revisions to the FAC 001 and FF002 on September 11, 2024, which is actually after we submitted some of our comments. And now, so this SAR is now in the commenting period, and it's going to be presented to the study committee in December 24 instead of November. I think it actually is, I can't remember the status of it now. But anyways, upon approval of the SAR, they were going to assign it to our group to take a look at. Just recently, to be honest, so our group did decline this SAR just because our team wasn't around the commissioning, where this SAR is looking a lot at some of the commissioning experiences, and we just didn't feel we could do it justice by taking it on. Now, the last thing, and I don't know, as I said on a couple slides ago, that as part of FERC 901, that now 2022-04 is anticipated to be a milestone 3 project. So it's still up in the air where we're going to end up there. Regardless, I'll just sort of give a highlight of where we were on the FAC 002 questions, and just for the FFC or questions, we modified the standard. We sent it out just for review, and as I understand, again, this is my first NERC group. We send it out for review first before the official ballot, so we get some industry feedback. And I do want to comment that there was about 10 parties that commented and gave a lot of feedback to the edits. And again, the first one was, do the proposed edits to FAC 002 ensure that the interconnection study process is clear on the modeling and study requirements needed to ensure reliable operation of the DPS, inclusive of EMT, modeling and studies? If you do not agree, or if you agree but have comments or suggestions, please provide your explanation. Next question we asked about the FAC, about the standard was, do the proposed edits to the standard address the need to collect EMT models and perform EMT studies without impacting the existing FAC 002 requirements? If you do not agree, or if you agree but have comments or suggestions, please provide an explanation. Third question we asked to the industry was, do the proposed edits to FAC 002 requirement 7 ensure that EMT models are made available to the TP and PCs during the interconnection study process? If you do not agree, or if you agree but have comments or suggestions, please provide the explanation. Now, do the proposed edits to the FAC 002 requirements R8 and R9 ensure that EMT model equality issues are resolved prior to commercial operation? If you do not agree, or if you agree but have comments, please provide suggestions or explanation. Now, just going back to here, you can see we have a wide mix of utility, consultants, OEMs. I can tell you coming up with those 4 questions took most of the time of the drafting of the standard. I also want to mention that we had one participant, as I mentioned, from Australia, that was helping with this, and a lot of his insight was really good. I mean, again, in my working life, I do a lot of work in Australia. They've created a complete EMT model of the entire AEMO system, and it actually gives us a lot of really good guidance about what to do, and more importantly, what not to put in a standard. So I think that type of insight was invaluable to what we had here. Now, again, we've circulated the comments around, and I would say mostly favorable comments. And by saying that, I would say they weren't mean. Most of the things were around the timing of models and the impact on including EMT modeling into the process. Again, I want everyone to just be assured that, you know, this is what we're trying to do here, is to come up, as I look at it, as a process and a standardization. One of the things that we're really struggling with is too many people doing too many things in isolation. And I think this is an extremely important opportunity for us to align on what is required. Again, the timing, I understand, you know, we're not looking to interject. And this goes back to one of the principal things that we said at the beginning of the standard, is that, you know, if we go right back to, where is it here? EMT studies where needed. I think it's important everybody keeps in context when we're looking at this. This is what we're talking about. We're not looking to redesign the entire interconnection process. We're looking to give guidance and provide some level of standardization into what we're doing here. Again, just because of the nature of the project that we're working on right now and going through some of the changes, we have the FAC 002. It was out for comment. We're updating it now. We've also are working with the Mod 32 group with my colleague here, and we're hoping to get those out for balloting this year, hopefully by Q2 of 2025. And then we're going to move on to the remaining standards. I just want to talk again about, just because a lot of the comments that came back from industry were about, we don't want to do this, this is too much work, and this is where we are. You know, this is a paper done in 2007. We had an inter-area oscillation that had to be solved with an SVC. In Manitoba, we created a complete model of the Manitoba power system in EMT tools with a vendor-provided SVC model that we did benchmarking against, right? This is stuff we were doing. This is, again, 2007. Or sorry, 2007. Now I'm going in the future, but so you can see that we've been doing this already, and this was not an inverter-based resource, it was an SVC, but it's showing that the principles that we're trying to use here have been around industry for a very long time. I also want to talk about this very interesting project we did in New Zealand. It was an HVDC project looking at connecting 2 island networks, right? It wasn't a grid forming inverter at this time. It was an LCC HVDC that doesn't have grid forming. But because of the criticality of this link between connecting the 2 islands, there was a tremendous amount of work done that they actually updated their planning process to drive this. And this included a tremendous amount of real-time testing against actual controls, hardware in the loop, this is one of the first instances where we were doing 1-for-1 modeling. So right now it's actually easy now. We just do a direct compile DLL and we can wrap it and we can run in PSCAD. This was before we had the ability to do this. This was what we were doing back in, again, 2015, looking at how can we make sure that, again, HVDC, the original inverter-based resource, how can it get integrated into the grid and how can it make sure that it's maintaining stability on everything we need to do here? So again, I just wanted to take some time here, like I mentioned, to give some comfort to people that we're not looking to redefine how everything is done. We're looking at this as a supplement where needed to help with the industry to help with this this great problem we have in front of us of integrating inverter-based resources. I guess that's it for me. Thank you so much.